Good morning, Year 4, and welcome to Tuesday's maths lesson. First of all, I'd like you to look at the mental arithmetic problems in front of you and have a go, please. Welcome back, Year 4. Let's have a look at the answers. So we can see that the method that we was using yesterday was subtracting three-digit numbers, and we were using partitioning to help us to do that. So what I mean by that is that mentally we were able to split the numbers up, partition the numbers. So 848, thinking of that number as 840 and 8, and thinking as 523 as 500 and 20 and 3, using that to help us complete our subtraction. So if I was doing 848 and I was going to subtract 523, then first of all, I'd be taking away the larger part of this number, the hundreds. So take away the 100, then I'm left with 348. Take away the 20, I'm then left with 328. Take away the 3, and finally I've got to 325. And also, if I take my answer and just check it using the inverse operation, which we know is add. If I add them together, I can clearly see they've made my starting number, so I'm able to do that double check just to check that I've got them right. Once you have marked those questions, then it's time to move on, please. So we're going to have a quick look at the Sapphire challenge for everybody. Now, although not all groups are doing this, all groups actually are going to be answering problems like this. So just a few quick reminders. When I'm reading a problem, I need to be underlining the key information. Josh has 15 sweets. There are 5 sweets in a pack. How many packs or packets does he have? So straight away, I can see that my operation to solve this is going to be dividing. And I'm going to be dividing by 5 because I've got 5 sweets in each pack. And my total to start with was 15. So one way of doing 15 divided by 5 is to take 15 objects or draw 15 counters, draw 15 sweets, and actually put them into groups of 5. And I can see by doing that I end up with 3 groups of 5. There's one, here's the second group, and here's the third group. Equally, when I'm dividing by 5, I can just count up in 5s. So thinking of my 5 times table, counting up in multiples of 5, 5, 10, 15. Now, when you come on to do this space race, it's all about how many 5s make this number. So I can see that 1 5 makes 5. And to make 15, I've got 1, 2, 3 5s. Again, if I wanted to, I could have taken 5 counters and put them into one group of 5. I could have taken 15 counters and put them into 3 groups of 5, as we've got here. Now, the rest of us are going to be working on the 7s today, but these same principles apply. Sapphire group, I'd like you to start your challenge now. So, similar to yesterday when we did the 6s, on the very first sheet of your worksheet, you've got a copy of this grid, and I'd like you to pause the video in a moment and write out 7 12 times, and then I'd like you to put 1 times and 2 times at the top. Pause the video now, please. Okay, so welcome back again, Year 4. If you have hopefully got this prepared, then you know that the first thing when we do 1, 5, 10 derive, the first thing we're going to do is put in that 1 times 7 is 7. Okay, not sure. Let's just make that a little bit more accurate how I've drawn that. 1 times 7 is 7. And then 10 times 7 is 70. Okay, should be finding that very simple if we are confident with our 10 times table. Half of 70 is 35, and also knowing my 5 times table, 5 times 7 is 35. Now once I've put in these 3 key facts, I can use them to help me work out the rest of the times table. So obviously double 7 is 14. If I double 14, then I've got 28. So 4 times 7 is 28. Now, knowing these facts here, I can think, what is 7 less than 28, or what is 7 more than 14? And 3 times 7 is 21. 70, add 7, 77. So 6 times 7 is going to be 1 more than 5 times 7. 5 times 7, 35. So 6 times 7 is going to be 42. I could double that to give me 12 times 7. So 12 times 7 is 84. And obviously that's 7 more than 77. Sometimes these are the areas within times tables, the 7 times, 8 times, 9 times, that we can find tricky. But using some of the skills we have done previously, if I know that 4 times 7 is 28, then I can double that to give me 56. 9 less than 10 is 63. And 7 times 7, 49. Okay, let's have a look then, please. Please do keep that to hand, because that's going to be very helpful for solving the problems today. So we're going to be solving problems using our knowledge of our multiples of 7, our knowledge of our times table for the 7s. We are going to be using division facts as part of that today. And hopefully some of us are going to be partitioning numbers into different multiples of 7 in order to solve some problems. First of all, can we just remind ourselves what a fact family is and actually have a go at one? So I've got 2 times 7. I'm going to write that in here. And the answer is 14. And I can see that the array on the left-hand side of the screen just here shows one group of 7, 2 groups of 7, 2 groups of 7, 14. I'd now like you to pause the video, complete the other 3 fact families. Okay, so I can see that this multiplication sentence here, obviously 2 times 7 is what we call commutative, which means that I can switch it around and do it in a different order. 7 times 2 is also 14. Now my related division facts, I'm going to need to start with my total. So I've got 14 in total. And if I work backwards using the inverse, I'm going to divide by 7, which is going to give me 2. So let's just look at how that looks like, what that looks like on an array. 14 divided into 7 groups. I'll be looking at the array this way, gives me 2. There's one group, here's the second group, and so on. Equally, if I take the total 14, working backwards using the inverse, 14 divided by 2 is 7. So I hope you got your family fact correct there. It's called a family just simply because we're using the same 3 numbers to write our 4 calculations. Hopefully you got that right. That's going to be useful for today. Now let's have a quick look at this problem. Billy has 56 sweets. There are 7 sweets in a pack. How many packets does he have? So, very similar to what the Sapphire group did. And first of all, we need to work out what is our number sentence. What is it that we actually need to do? What is the operation that we're going to be performing? Well, if I've got 56 as my total, and I'm putting that total into packets of 7. So I often like to visualize a maths problem. I can actually physically see myself 56 sweets in front of me and actually putting 7 into one packet, 7 sweets into another packet, and so on. Now, when we divide by 7, we know that that means we can count up in 7s. Okay, so we could easily show that on a number line, and obviously we start at 0, and we're going to 7, 14, hopefully you're already ahead of me, 21, 28. Okay, I apologise for the big jump there, tricky using the mouse pad today. 35. 42. 49 and 56. And hopefully you've already worked out that we've got 8 jumps of 7. Okay, I can count my jumps. Okay, each of these jumps I was effectively adding 7. Okay, I could write that the whole way along. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my answer is 8. I appreciate lots of us could do that without drawing a number line. For some of us who don't know our sevens as well, then drawing out a number line would be a good skill that we could use. Just showing what that would look like on a bar model. Well, we're counting 7s, so we've got 2 7s, which is 14, 3 7s, 21, and we continue with our 7s until we get our total, which is 56, and we know that 8 multiplied by 7 is 56. Okay, and just because it's important, let's just see what that would look like as an array. We've got 3 lots of 7, 4, 5, 6, 7. Whoops, looks like we've just got 6 in there, so let's just copy 2 more of those. So 1 group of 7 and 8 groups of 7. This is what that would look like, okay, as an array. So just seeing how we represent that in different ways. However, the key bit is just to have the number sentence, and if we can count up in 7s, we've solved our problem. So if you are not 100% confident with the 7s, I would like you to start your work now. Choose the bronze challenge. Doesn't matter if you've often been choosing the silver or the gold. If you're not confident with the 7s, then please complete those problems there. Move on to task B, and then you might feel confident enough to have a go at task A on silver as well. We're now going to focus on looking at silver task B and gold challenges. So anyone doing those will need to continue to watch the video, please. Now, from this problem, you will see straight away that this is above 12 times 7. So it's above 84. So how many multiples of 7 is 98? Okay, we've got exactly the same problem, 98 sweets, 7 sweets in a pack. How many packets? Our number sentence is going to be 98, and we're going to be dividing that by 7. But I'm not sure I know 13 times 7, 14 times 7, as well as I do the rest of my table facts. So let's consider how we could break down 98. And some of you looked at this yesterday. If I take 98, I could actually partition that, and we can still call it partitioning, because partitioning just means splitting up the numbers, into 70 and 28. 70 and 28 makes 98. Why have I chosen 70? Because it's below 98, and it's very simply 10 multiples of 7. I know that 70 divided by 7 is 10. I then work out how much have I got left from 70 to get to 98. It's 28. 28 I recognise as a multiple of 7. You can see it down the bottom here, and it's my 4th multiple of 7. So 28 divided by 7 is 4, meaning that 98 divided by 7 is 14. Now again, I appreciate that there's a few people could have done that without writing out their working in their head, but the numbers are going to get larger. The multiples of 7 are going to get larger, and being able to write it out in a systematic way like this means that you're going to be accurate. So I'd like you to show your working today, please, for your problems. Let's have a look then at some other challenges that you're going to face. So I talked about then a number getting larger. So if I was going to do 161, I would still, first of all, consider 70 divided by 7. And then I could do a second 70 divided by 7. So I know now that I've done 140 divided by 7. Okay, perhaps some of you would have preferred just to have written 140 divided by 7 rather than 70 divided by 7 twice, and that's absolutely fine. But again, for some of us, partitioning a number for the first time to divide by 7, it's good to see why we do 70 divided by 7, because it's 10, and another 70 divided by 7 is 10, hence this would be 20. So if I'm at 140, what have I got left to get to 161? Well, it's 21. Okay, 140 add 21 gives me my 161. And I know that most of us are fairly familiar that 3 sevens, or fairly familiar with this division fact, 3 sevens are 21. So hopefully you've just worked out then that if I do 161, so let's just write my number sentence down. And again, I would like you to do this when you show your working, please. I'd like you to write down the number sentence that you've got to solve. And then I'd like you to show how you partition it. Okay, so I don't need to have written it 2 ways. I'm just showing you that there is a more efficient way, but it is very important about being 100% accurate. So the answer to this problem is 23. Okay, 161 divided by 7 is 23. And I've proved that by partitioning the number 161 and just dividing it by 7 and then recombining. Okay, something that we talked about in our mental maths at the start of the lesson. Okay, pushing ourselves a little bit further then. What about a problem like this? Billy has got 320 sweets. He's still going to divide them by 7. Now it says how many full packets does he have and how many are left over. So this tells me that there's going to be some remainders. Some of us have done division before and had sweets or remainders left over. Okay, we've had some remaining sweets. So let's just write down our number sentence first of all. We said we'd always start with that. So we've got 320. We're dividing by 7. And again, I need to now partition 320 in order to solve my problem. So I could do 70 divided by 7, but we did work out earlier that 140 divided by 70 would, divided by 7 would be 20. I could now do another 70, that I know that I'm now at 210, divided by 7 is going to be 10. I could do another 70 divided by 7 is 10. Currently I'm at 280. Okay. Perhaps some of us saw this number 32 and thought, well, I know that 28 divides by 7, and maybe thought that actually a quicker, more efficient way than doing all of this could have been to have done 280 divided by 7. Okay, if I know that 28 divided by 7 is 4, then 280 divided by 7 is going to be 40. Doesn't matter if I've done it more in a longer way, as long as I am accurate. Okay, but if I can do it more efficiently, then I should choose that option, as long as I'm accurate. Always use the inverse still. 7 times 4 is 28, therefore 7 times 40 is 280. So, okay, what have I got left then to get up to 320? Well, I'm left with 40. 40 divided by 7, okay? Now, if I think back to my multiples of 7, I know that 35 divided by 7 is 5. Okay, let's just write that down here at the bottom. 35 divided by 7 is 5. So 40 divided by 7 is going to be 5 then, but I'm going to have 5 sweets left over, because 40 is 5 more sweets, isn't it, than 35. Okay, so I can put a little r meaning remainder, and I can say that I've got 5 sweets left over. So how many did I have left over? The answer was 5. And how many full packets did I have? Well, I had 40 and I had 5, so my answer was 45. Okay, I appreciate there's quite a bit of working on here, so I'm just going to double check that. Really important to be accurate, isn't it? Okay, let's actually use these black numbers here. So I had to divide 320 by 7. So I did 140 divided by 7, okay, and that was 20. And 70 divided by 7, and that was 10. 70 divided by 7, that was 10. And effectively, I'd done 280 divided by 7, which was 40. Then to go from 280 to 320 is 40 more. Okay, I haven't written 40 here because my answer 40 is here. I've written it because I've still got 40 more sweets. I've already divided 280, but I've got 40 left to still divide by 7. When I divide that 40 by 7, then I've got 5 groups. Okay, so that gives me 45 full packets. Okay, however, I have got 5 sweets left over. So my answer is 45 full packets with 5 left over. One final challenge to have a look at then. Now, this question is very similar, but on this occasion we're dividing by 70. Now, I'm not actually going to solve this one for you, but what I'm going to do is just show you a way that you can simplify the question. So 1,610 divided by 70. Okay, that's my problem. I've got 1,610 sweets. There's 70 in a box. Okay, it's a box this time, not packets, but same principle. How many boxes? Okay. Now, some of you might be feeling a little bit unsure about counting in 70s. However, what I can do, if I make this side 10 times smaller, so that's going to be 161, and I make this side 10 times smaller, so that's going to be 7, I can actually do 161 divided by 7, and it will give me the same answer as 1,610 divided by 70. And all I've done is made each side both 10 times smaller. The trick there is to do the same to both sides. If you make one side 10 times smaller, but keep this at 70, it's not going to work. Okay? Or if I just divide this by 7, it's not going to work. But if I make both sides smaller, you get the same answer. So I'd like you to try that, and then when you check your answer using a calculator, you'll see that that is true. Now, when you work through the problems, goal challenge, there is a tricky challenge on D, but I have provided the answers for that for you. So for the majority of your calculations today, you can just check them using a calculator as a straightforward division calculation. Just be aware, if you're doing gold task B, that there is remainders. Therefore, if you use a standard calculator, it's going to show the remainder as a decimal, which can be quite difficult to understand. Therefore, you must use this web link here, which takes you to Math Warehouse, an American website, which provides an online calculator. And once that's loaded up, we can see if we divide 70 by 7, so I just put the numbers into here, that the answer is 10. We knew that. And if I put 71, I should still get 10 groups with 1 left over. 71 sweets divided by 7 would be 10 groups with 1 left over. Now, it shows it as an array, and we can see the 1 left over here. We don't need to worry about this long division, and we don't need to worry about all the kind of extra bits of information that are on that page. The main part is here, if I was going to do 35 divided by 7, we know the answer is 5. I can see there my array, groups of 7, I've got 5 of them. and let's say we did 37, I would have, 2 sweets left over. 5 remainder 2, and there I can see the 2 left over. Okay, but be warned, if you do this on a normal calculator, it's not going to say 5.2. Okay, so it's giving you a decimal answer rather than a remainder. So for remainders, I need to be using this website. Good luck today, Year 4. Hope everything goes well for you, and look forward to speaking to you again tomorrow. Thank you.